Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is find all the duplicates in an array. So you will be given an integer array of length n where all the elements are in the range 1 to n. N is the size of the array, both 1 and n inclusive, and each integer appears once or twice. So you have to return an array of all the integers that appears twice. So you must write an algorithm that runs in linear time complexity and it uses constant extra space. Okay, so let's have a look at the constraints. So the length of the array will be length, which is of order length of array will be n, which is of order 10 raised to power 5, and each element will be lying in the range 1 and inclusive. So and each element will either be appearing once or twice. So let's see how we can solve this particular problem. So to solve this in linear time complexity, what we can do is we can leverage this fact that all the integers of nums array are in the range 1 to n. Okay, so instead of using a map or something to keep track of elements which are already visited, we can use this fact. How we can make use of it? Let's see. So let's take one of these examples. Let's take this as our example. Okay, so let's mark the indices first. Okay, before proceeding with any solution. Since it was mentioned that let's say size of this array is n, and it was mentioned that all the elements will be ranging from 1 to n. So we can consider elements as the indices of this array. Okay, but since it is at 0 based indexing, so we'll subtract 1 from the element value. What I mean by this is, let's say we are at 4, then 4 minus 1 will be 3. Why I am subtracting 1? Because the indexing will be a 0 based indexing, and if let's say the size of the whole array is 8, and 8 is also occurring here, as you can see. So what will be the index? If you take 8 as index, it will not be present in the array. Why not? Because in 0 based indexing, indices start from 0 and end at n minus 1. So that's why we are subtracting 1 from each element, and corresponding to that index we will change the sign of that index, element present at that index. What I mean by sign, if it is positive, you will make it negative, and initially all the elements will be positive, since it is mentioned that elements range from 1 to n, both inclusive, so there are no negative elements. Okay, so with this help, whenever we are visiting an element, and that, let's say this is the element that is being visited, and when we subtract 1 from that element, we will get the index. Okay, so at this index, if there is an element which is already negative, it means that we have seen uh, let's call this element instead of index element. Okay, this index element, if happens to be already negative, then we will see that say that, you know, this particular element have already been seen. Okay, already been seen. Okay, it means that it is being repeated, and we will instantaneously come to know that okay, this is the case. Then you will, what you will do, you will simply, you know, add it to the duplicates array that you will be returning. Okay, so let's have a dry run of this particular one. Okay, starting with the very first index. As you can see, 4 minus 1 will be 3. So going to the third index and making it negative. It was not already negative, so 4 is not a duplicate number. Then coming to 3, then 3 minus 1 will be 2. Coming to the second index and make it negative, it was not already negative, so 3 is also not repeated. Then coming to this number, so 2 minus 1 will be 1, so making element at 1 index negative. It was not already negative, so this 2 is also not repeated yet. So after we cross 2, then we come to 7. Then first of all, I would like to also mention that when we are taking negative of a number, we will first of all do absolute of that number, since that number must have been used to represent some other number. Okay, occurrence of some other number. So we will take absolute of minus 7 and then subtract 1 from it. So it will be 6. So at the sixth index we will see, well, is a negative number? No, then we will make it negative. So then coming to 8, after it you can see that you know, 8 minus 8's absolute minus 1 will be, so 8 minus 1 will be 7, so we will make it negative. Then coming to 2, so 2 minus 1 will be, absolute of 2 minus 1 will be nothing but 1. So we will see what is the number at the first index, and we come to know that okay, it's already negative. Okay, so you will instantaneously know that 2 is a repeated number, so you will add it into the duplicates array. Okay, same thing you will doing for every number that is there. And so you know, when you will be at minus 3, you will take absolute and subtract 1, and then you will see what is the index coming out. It is 2. So when you are at this one, so you will see at the second index, okay, second index is again, you know, already negative. Okay, so you will add 3 also in duplicates, then you will continue with in this fashion, and at last minus 1's more absolute value, and minus 1 will be 0. So we'll see at the 0th index it is not already negative, make it negative. And yeah, that's pretty much it, and we are done. So these are the duplicates. So what was the logic? That we are, you know, leveraging the fact that every entry in this particular array will be ranging from 1 to n, where n is the size of the given array. And why we are subtracting -1? Because it is a zero based indexing. As I told you, the whole length of this particular example was 8, and 8 is also occurring, so 8 will never be an index. It will be from 0 to 8 minus 1. So that's why we are subtracting 1 from each index, each number. And before that, I would also like to mention that we are taking absolute values of each element first. Why so? Because that element could have been used by another element to represent itself, its occurrence. Okay, that's why. So let's implement this logic and solve this particular problem. I am taking result. You can take duplicates also. It's totally up to us. So let's take duplicate only. Okay, and let's do the indexing thing. Okay. So we will be traversing this array once. And for the every element that we are encountering, we will find the corresponding index. Let's call this element index, which will be nothing but absolute value of element right now, and -1. Okay, so we will, you know, uh, make the number present at this element negative. So what we'll be doing is integer nums of element index will be made negative, or you can just multiply it by -1. This will do the required thing. Okay, but before that, what we will be doing is we will be checking whether the number is already negative or not. Okay, if nums of element index, I mean the number at this particular element index, is already negative, then it means that it is being repeated, and in that case, you know, you will be adding it to the duplicates. What number you will be adding? The number that we are visiting. Okay, or you can more specifically call it current number if you are having a little bit of confusion here. Okay, so current number would be fine. Here also. Okay, and if that's not the case, you will simply make negative element present at the element index in order to represent occurrence of current number. Okay, occurrence of current number. So yeah, that's pretty much it, and at last we should be returning this duplicates array. I think this should work. Let's try to submit for sample test cases, and if not, we will do some modifications for sure. Okay, we haven't pushed back here. Okay, for once it's giving some kind of error. Okay, while pushing a number, you should also take absolutes, since it must have been used by some other number to represent its occurrence. So that is fine. Yeah, it's getting accepted for at least sample test cases. Let's try to submit it for final evaluation. As you can see, it's getting accepted for all of the test cases that were out there. So this is how we will be solving this particular problem. I will again explain briefly what we just did here. We leverage the fact that each number will not be negative and it will be ranging from 1 to n, where n is the size of the given array, both inclusive. Okay, so we can represent occurrence of each numbers with the help of indices of this particular array. And since indices will be zero based indexing, so that's why we will subtract 1 from each element to find out the index which can represent this number. Okay, and before doing that, we will also take absolute of the current number. Why we are taking absolute of current number? Because it will sometime happen that this number would have already been used by some other number to make mark for its occurrence. Okay, so 7 was already used by some number, because what number have used 7? You can very well see here. 4 minus 1, if we talk about 4 minus 1 will be 3 initially, and it will give us index 3. So index number present in index 3 is 7, so that's why 7 is already marked negative for indicating occurrence of 4. Okay, so we must take absolute of every number before finding out the index to represent its occurrence. Okay, so now once we have done this, we will push the duplicates and we will be pushing the absolute value of numbers. Okay, since they would have been used by some other number to represent its occurrence, so that's why taking absolute is necessary here. Okay, this part I hope you are able to understand. As far as space and time complexities are concerned, you must have guessed that we will be using linear space, a linear time complexity and constant extra space. Okay, so if we do not count the space required to store the duplicates, so that is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.